Hi everyone and welcome to my YouTube channel. So we'll be continuing our IMO past problems playlist, and in this video we'll be continuing the fifth IMO, which we discussed like the problem 1 in the previous video, and in this video we'll be discussing simply problem 4. So as I told you, like this IMO unfortunately is a bit boring because like problem 1, as we saw, was a boring equation, and this also problem will be like kind of boring, also like a system of equations. Alright, so again, if you are my dear friends are ready to get bored, then let's get started. Alright, so the problem statement goes as the following. So in this question we need to find all solutions x1, x2, x3, x4, x5 of the following system of equations, like x5 plus x2 equals yx1, x1 plus x3 equals yx2, and so on, like a cyclic thing, x5, x1, x2, x3, x4, then 2, 3, 4, 5, 1, and 1, 2, 3, 4, 5. So like a cyclic thing. Of course, like y is the parameter. So this is a similar like to the previous question. However, the previous question, like problem 1, we also had a parameter, but it was just a single equation. Here we have a system of equations. Alright, so what exactly can we do here? Let's have a look at our equations. So like they seem a kind of simple, like sum of 2 equals y times like something, and so on. So like usually in IMO problems, like they are not, we don't like go brute forcing. For example, like we don't like find x5 in terms of like other stuff and x4 in terms of other stuff, because this will be boring. So instead, like we try to find some tricks. For example, what happens if we add equations, if we like add and subtract and stuff like this. So for example, here actually, if you take a look, like it's really like we have a motivation to add all of everything. If we have like if we added everything here, we'll have actually 2 times the sum equals y times the sum. So that means we have two cases: either the sum of the numbers is 0 or y equals 2. Okay, like actually you can discuss y equals 2 in this case. You will get like something easy, like if you want to try to discuss it immediately. But the problem is like with the other case, if their sum is 0. So when their sum is 0, like actually you will not be able to really like operate nicely, like you don't have some like tricks or whatsoever. So like unfortunately this problem is really boring, that we'll really need to actually just go and brute force. Alright, so like let's hope that this is not that complicated, because like everything here is kind of linear. So let's hope like we don't get like complicated stuff. Okay, so without further ado, like let's start. So first of all, we have x5. We have like, of course, what is the plan? We have numbers like x1 up to x5. So we want like to get rid of the big ones. For example, x5, write it in terms of x1, x2, and so on. Like try to do this as much like as possible. So first of all, from equation number 1, we can simply get the value of x5 using just x1 and x2, which is very good. So let's do that. So first of all, x5 is nothing but y x1 minus x2. Alright, this is already very good. We're done with x5. What about x4? Okay, so actually like right now in the second one, we have x3. We can find actual x3 in terms of x1, x2, which is also very good. So simply we can write x3 is equal to yx2 minus x1. Alright, now we got rid of x3. Okay, next our plan is simple. We want to get rid of x4. So also like we have here x4, we can simply find it in terms of x3 and x2, but guess what? We already know what is x3 in terms of x2 and x1, so we can just write x4 in terms of x1, x2. However, like it will be like a quadratic form of y. We will have y squared, but no problem. Like we already like get rid of two things using the linear y, so like it's like no problem at all. Okay, so let's just do that. So simply x4 is equal to yx3 minus x2, and we already have like the value of this, so it's just y square x2. Well, we can already write it like y square minus 1x2 then minus y x1. Alright, so now we have our value for x4 and we're ready to proceed. So now we have found the values of x5, x4, x3 in terms of x1, x2. Now we're ready just to use the final equations, two equations, in order to find the solutions. Alright, so now we have x3, x5 and x4 all in one equation. So we'll simply substitute what we have, we have x3 plus x5. So we'll just add these two things here. We'll just actually have y. Okay, let's immediately do something nice. So for example, if you add this and this, you'll have y minus 1 x1, and then you have also y minus 1 y minus 1 x2, and this thing is equal to y times x4, which is simply y times y minus 1 x2 minus y square x1. Alright, let me make sure we didn't make any mistake here. Okay, it was x3 plus x5 and y minus 1, then y minus 1 x2, correct. Okay, then we multiplied and then minus y squared x1. Yep, I think everything is correct. Okay, now of course let's isolate x1 and x2. So that just means that okay, we can take y minus 1 as a common factor. Okay, if we move this thing here, we'll have y minus 1 outside, and we have y times y plus 1, which is just y square plus y minus 1 times x2. And then of course we can write plus. We do the same thing, but now actually we have minus if we move that there, it will be like this. Yes, this is better to write y square. Okay, so here if we move this thing here, we'll have it be negative. So now if we take a negative, we'll have y square minus y plus 1 times x1 equals 0. Alright, so as you can see, we have a very nice thing. We have this thing here and here, so we can take it as a common factor. Alright, so it seems that it's not that ugly, because now we simply have y square plus y minus 1 times y minus 1 x2 minus x1 is just equal to 0. And now we have the simple stuff, either this is 0 or this is 0. Alright, so this is a very good equation. But before we discuss, of course, let's go ahead and proceed with the last equation, which we didn't use yet. So we need now to add x1 and x4 to get y x5. So x1 plus x4, where is x4? Here it is. We just need to add x1. So here, just make this 1 minus y. Alright, let's do that. So y square minus 1 x2 plus 1 minus y times x1 is equal to what was it? Yes, y x5. Y times, okay, let's expand it immediately. Y square x1 minus y x2. Alright, now let's go ahead, isolate. So y square, okay, so it's y square plus y minus 1 times x2. Then of course we have the same thing here and here, plus, I think it should be minus, it should be better, yes. Then y square plus y minus 1 x1 equals 0. Guess what? We got this again, so this is very good. You can take it a common factor. And now we have y squared plus y minus 1 times x2 minus x1 equals 0. Now that's a beautiful equation. Alright, so actually like we need to keep this in mind and this in mind. Like this was 1, this was 2. In order. Okay, so now like if we take a look at these two, like we have y squared plus y minus 1, it's repeating again. So now we have two cases. Like either y squared plus y minus 1 is 0 or no. So if this like was 0, so if we can find y, of course, like it will be, we have two solutions for y, but then we don't have any other condition because like this, like we don't care, this is always true and this is correct. So no conditions on x1 and x2, and we already like found x3, x4, x5 in terms of x1, x2. So actually we're done in this case. So the other case, which is like more here like important, is if this was not 0, then of course we'll have like from here x1 equals x2, and then from here like if x1 equals x2, we can simply take x1 as a common factor. We'll just have actually y minus 2 times x1 equals 0. So y minus 2 times x1 equals 0. So that means either y equals 2 or like x1 equals 0. So actually if x1 equals 0, then like x2 equals 0, then everything is 0. From here you can see that everything will be 0. So 0, 0, 0, 0, 0, 0 is a solution no matter what is the value of y. If not, then y equals 2. If y equals 2, then like if y equals 2, then of course we know x1 equals x2, and this is correct now. Now if you just go ahead and plug like y equals 2 here, you will get that like actual x5 equals x1, x3 equals x1, and even x4 equals x1. So that means like any like same solution will like be correct. So like a like whatever the value of a, any real number, of course with the condition that y equals 2 is a solution. And finally, like we don't have any conditions if y squared plus y minus 1 equals 0. So that simply like leaves us with these cases. Let's discuss them. So case 1, y equals 2. In this case, if y equals 2, then as we agreed, we'll have like simply x1, x2, x3, x4, x5 are all equal. Let's say like a for any real number a. Okay, case 2. Alright, we can simply like solve y squared plus y minus 1 equals 0. Like it is easy stuff, like delta is simply 1 minus, okay, so 5, so root delta is root 5, so simply, okay, so now minus 1 plus minus root delta, which is root 5 over 2. Okay, so in this case, like we found the value of y, and if we found the value of y, as we said, like now we don't have any other conditions. So that means like simply x1, x2, x3, x4, and x5 is just equal to any numbers right now, a and b. Then like we can simply substitute from there what we got. Okay, so for example, here we have yb minus a. Okay, this one is yb minus a, this one is ya minus b. So now first of all, let's write yb minus a. Here we have ya minus b. Now like for actually for number 4, we have okay, x4, we have y squared minus 1, x2 minus y x1. But guess what? We already know that y squared plus y minus 1 equals 0. So we can simply substitute like y squared minus 1 with negative 1. So we can simply say that negative or minus y x2 minus y x1. Okay, so minus ya minus yb minus ya minus yb. And hence now like we're done actually. Of course, like y here, I'm putting y because I don't want like to write this thing again and again. But we already like know the value of y. So like we can just put this here, like two cases for y. And finally, case 3. In case 3, of course, if y isn't equal to the, like, let's say else, then we already showed that actually x1, x2, x3, x4, x5 is just 0, 0. And here, like, we don't have any conditions. And so, my dear friends, these are the 3 solutions, and we are done. Alright, so as a summary, in this question, we had a system of like linear equations with a parameter, of course, y. As you saw, like, the only thing that you did actually was clear brute force, nothing like special here. Like, of course, usually you will not see this in IMO again. Because right now, like, usually there are some, like, if there is like a system of equations, usually, like, there is some tricks out there, like you want to add stuff, you want to multiply by thing or something like similar. However, like, this question was really standard. You just like brute force everything, and luckily, like, we don't get like ugly stuff. Everything is easy, everything is simple. All right, my dear friends, so finally we're done with this boring like IMO problem 1 and problem 4. And in the next video, of course, we'll be continuing with our 6th IMO, which is IMO 1964. So I hope you guys enjoyed again this awesome IMO. Please like, share, and subscribe to the channel, and see you guys in the next video.